In this video, I'm going to discuss the distance formula. Now, the distance formula is another application of the Pythagorean theorem, and I'll get to that and show you how in a moment. But the distance formula itself is going to be d equals, and then you have this radical that's going to contain a lot of stuff inside here. So it's going to be x2 minus x1, and that quantity gets squared, plus y2 minus y1, and that quantity gets squared. So whatever we get when we add all this business together, we'll take the square root of that, and that'll be our distance. So we have this x2 and x1, and y2 and y1, and this just means the points are going to be x1, y1, and x2, y2. So the distance formula is going to be the distance between 2 points. So we have a point here and a point here, and we're going to plug those values into this formula, simplify, and there we have a distance. So let me show you why it uses the Pythagorean theorem. So in this example, I have 2 points. I have 1, 1, and I have 4, 5 as my ordered pairs. So if I draw a line between these two and say, I want to find the distance here, it looks like it's not going to be a nice number. It doesn't follow along any grid lines, and it's certainly not anything that is obvious to me for a distance. But I can make a right triangle out of this by going down and going over and connecting these lines. Well, what's going to be the height of this right triangle, and what's going to be the base of this right triangle? Well, if I count, I go 1, 2, 3, 4, so my height will be 4 units. And when I count over 1, 2, 3, my base will be 3 units. So if this is the case, I know that I can take a squared plus b squared equals c squared, the hypotenuse of this right triangle, in order to find its distance. Okay, so 3 squared will be 9, 4 squared will be 16, and 9 plus 16 is 25. So it'll be the square root of 25, which is 5. So this distance that looked kind of crazy, that we weren't sure what it was, that kind of cut across all these grid lines, is actually 5 units. And this is a 3, 4, 5 right triangle. So let's see what that looks like if we were to put this into an example using the distance formula. So our 2 points that we had were 1, 1, and 4, 5. Okay, so if I call this x1 and y1, and this is x2 and y2, then it's just a matter of plugging this stuff into our formula. So d equals the square root, and I'll draw it long, I'm not sure how far it'll go, or that I really need it, but x2, that's going to be 4, minus x1, which is 1, and quantity squared, plus y2, which is 5, minus y1, which is 1, quantity squared. That's kind of the end of that radical. So now that I've plugged my values in, let's go ahead and simplify. So 4 minus 1 is going to be 3. So I'll have 3 squared plus 5 minus 1 is 4 squared. That'll be the square root of that. 3 squared is 9. 4 squared is 16. Looks familiar for what we just did a while ago. The square root of 9 plus 16 is 25 equals 5. So the distance that we have here is 5 units, which we found by making a triangle on our coordinate plane. So the distance formula works just the same. Well, let's compare these two things and see exactly what we just did. So if I drag my triangle over here, I notice that when I took these distances, 4 minus 1 to get my 3, isn't that just the base here? 4 minus the 1 is 3 units long. So the other one is 5 minus 1. So up here at 5, 5 minus 1 is 4 units. So my formula actually is doing the counting or doing the subtracting for me to find the side lengths of these right triangles. And once I have the side lengths of these right triangles, I can square each of them. So this squared plus this squared, and then take the square root to find that hypotenuse. So that's how my distance formula is going to work. In our next example, I'm going to find the distance between the points 4, 7 and 7, 3. So I already have written my distance formula here, where it's the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Okay, so what are my values of my x's and y's going to be? Well, I can make this one my first point and say x1, y1, make this my second point and call it x2, y2, and now that I have numbers, it's just a matter of plugging them in and seeing what I get. So x2 looks like it's going to be 7, x1 is going to be 4, so I'll put parentheses around that and say square it, plus y2, it looks like 3 minus y1 is going to be 7, square that, and then that whole thing under a square root. Okay, 7 minus 4 is going to be 3, so 3 squared, and 3 minus 7 is going to be a negative 4, so that's going to be squared, and then I'll have it just like that. So, whenever I do this, 3 squared is going to be 9, negative 4 squared is going to be 16, and it's going to be the square root of 25 again, and it'll be 5 units. So that's another example. In this next example, we're going to find the distance between negative 3, 13 and the point 3, 7. So let's go ahead and label these things. This first one will be our first point, so this will be x1 and y1. The second one will be our second point, so let's call this x2 and y2. And then it's just a matter of plugging these values in. So we're going to say it's the square root of x2 is going to be 3 minus x1, which is a negative 3. I'm going to square that. Notice that since this was a negative, I put this negative value in parentheses. That way it's easier to see what we need to do. Our y2 is 7 minus y1, which is 13, and that stuff will be squared. Okay, let's just continue on. Now I see that this 3 minus a negative 3. I can actually make that 3 plus 3, so that's going to become 6 quantity squared plus, and this 7 minus 13 will be a negative 6, and that's going to be squared. So when I square each one of those, it's going to be the square root of 36 plus 36. Okay, well, moving on, we know the square root of 36 plus 36 is going to be 72, and now it's a matter of simplifying this radical. So we can bring it down here and find the prime factorization of 72. So we can take a 2 out of there first and get 36. Another 2 will give us 18. Another 2 will give us 9, which is no longer even, but we can take a 3 out to give us 3, and one more 3 to give us our 1, which we're looking for. So I can rewrite this, the radical of 72, as 2 times 2 times 2 times 3, which is our prime factorization. So it looks like this pair of 2's and this pair of 3's will both come out. So it'll be 2 times 3, and this 2 didn't have anybody to pair up with, so he stays in there. So our final answer for the distance looks like it's going to be 6 times the square root of 2. So 6 radical 2. In this final example, we're going to find the distance between the ordered pairs negative 3 radical 3, 7, and 2 radical 3, negative 4. So in this case we have some radicals to deal with, but the process that we use to do this won't be any different. So let's go ahead and start our business. So we're going to do the square root, and our x2 is going to be, let's go ahead and label these x1, y1, x2, y2. So our x2 will be 2 radical 3, and we're going to subtract x1, which is negative 3 radical 3, and that's going to be quantity squared. We're going to add that with y2, which is negative 4, minus y1, which is 7, and that's going to be quantity squared. So when we look at this, 2 radical 3 minus a negative 3 radical 3, well, when we subtract a negative, we're really adding, and it looks like 2 plus 3 will be 5, and the radical 3 is like a like term, so it's like saying 2x plus 3x is 5x, except this radical 3 is going to be this thing that we're looking for like terms. So the 2 radical 3 plus 3 radical 3 makes 5 radical 3, and that'll end up being quantity squared plus, and then a negative 4 minus 7 will be a negative 11, quantity squared, and then there we go. So we talked previously about how do we square this square root business. So we're going to distribute this squared to both of those terms. So it'll be 5 squared, which is 25, times just 3, because the square root of 3 squared is just 3. So 5 times 5 times 3, which will be 75. And then negative 11 squared will be 121. So it looks like it'll be the square root of 75 plus 121, which as we move this up, we'll notice is going to be 196. Now if you know some perfect squares, you know already that 196 is a perfect square. But if you don't know it, let's go ahead and work this thing a little bit. So we can divide it by 2, and we'll get 98. Divide it by 2 again, and get 49. 7 will give us 7, and another 7 will give us 1. So this radical will be 2 times 2 times 7 times 7. So the 2's and the 7's will both pair up and come out. So 2 times 7 equals 14. So our distance ended up being an integer, even though we started with having radicals in our ordered pairs. So the distance in this case is 14.